Hello students, welcome back to our science video. For today's lesson, we will discuss a specific group of atoms or bonds within a compound that is responsible for some chemical reactions. At the end of this lesson, viewers are expected to describe and cite applications of the different classes of organic compounds. A functional group is a specific group of atoms or bonds within a compound that is responsible for the characteristic chemical reactions of that compound. The same functional group will behave in a similar fashion by undergoing similar reactions, regardless of the compound of which it is a part. Functional groups also play an important part in organic compound nomenclature. Combining the names of the functional groups with the names of the parent alkanes provides a way to distinguish compounds. These are the list of common functional groups of hydrocarbon derivatives: alcohol, ether, aldehyde, ketone, carboxylic acid, ester, amine, and amide. Alcohols are those organic compounds which are characterized by the presence of one, two, or more hydroxyl groups that are attached to the carbon atom in an alkyl group or hydrocarbon chain. These alcohols are considered to be as the derivatives of water, where one among the hydrogen atoms are replaced by alkyl group, which is typically represented by the letter R in an organic structure. Alcohol also comes in different structures and forms. They are also known to be among most of the commonly occurring organic compounds. These are utilized in the form of sweeteners, preparation of perfumes, and sometimes in the process of synthesizing other compounds, wherein some others are abundantly manufactured in an organic chemicals coming in various industries. According to the IUPAC nomenclature system, an alcohol is named by dropping the terminal E of the parent carbon chain, like alkane, alkene, or alkyne in most cases, and the addition of -ol as the ending. And here is an example of some alcohols: methanol, ethanol, propan-1-ol, and butan-1-ol. Properties of alcohols. Due to the presence of an OH group, alcohols can hydrogen bond. This leads to higher boiling points compared to their parent alkanes. In general, the boiling point of alcohols increases with an increase in the number of carbon atoms in an aliphatic carbon chain. Second, the solubility of alcohol in water is governed by the hydroxyl group present. The hydroxyl group in alcohol is involved in the formation of intermolecular hydrogen bonding. Thus, hydrogen bonds are formed between water and alcohol molecules, which make alcohol soluble in water. And lastly, alcohols react with active metals such as sodium and potassium to form the corresponding alkoxide. These reactions of alcohols indicate their acidic nature. The acidic nature of alcohol is due to the polarity of an OH bond. The acidity of alcohols decreases when an electron-donating group is attached to the hydroxyl group, as it increases the electron density of the oxygen atom. Thus, primary alcohols are generally more acidic than secondary and tertiary alcohols. Types of alcohols. Alcohols are differentiated based upon the presence of hydroxyl group attached. The location of this hydroxyl group as well will change the physical and chemical properties of any alcohol. There are three types of alcohol. Alcohols are classified as primary, secondary, or tertiary alcohols. The classification is done in accordance to where the carbon atom of an alkyl group is attached to the hydroxyl group. Most of the alcohols are known to be colorless liquids or even are said to behave as solid at room temperatures. Alcohols with less molecular weight are said to be highly soluble in water, and with their increase in molecular weight, they tend to become less soluble and their vapor pressures, boiling points, densities, and the viscosities to increase. Primary alcohols are those alcohols where the carbon atom of the hydroxyl group is attached to only one single alkyl group. Some examples of these primary alcohols includes methanol, ethanol, and prop-1-ol. The complexity of this alkyl chain is unrelated to the classification of any alcohol considered as primary. The existence of only one linkage among OH group and an alkyl group and the thing that qualifies any alcohol as a primary. Secondary alcohols are those where the carbon atom of the hydroxyl group is attached to two alkyl groups on either side. The two alkyl groups present may be either structurally identical or even different. Some examples of secondary alcohols are given below: propan-2-ol, butan-2-ol, and pen-3-ol. Tertiary alcohols are those which feature hydroxyl group attached to the carbon atom which is connected to three alkyl groups. The physical properties of these alcohols mainly depend on their structure. The presence of this OH group allows the alcohols in the formation of hydrogen bonds with their neighboring atoms. The bonds formed are weak, and this bond makes the boiling points of alcohols higher than its alkane. Uses of alcohols. There are several uses of alcohols. First, alcohols are consumed as beverages where the alcohol specifically consists of 30 to 40% of ethanol by volume. Second, these are used as an anti-freezing agent with a mix of a solution containing ethylene glycol dissolved in water. Next, alcohol ethanol is used as an antiseptic agent. Fourth, some alcohols are used as fuels in the internal combustion engines like the methanol. And lastly, in the field of medicine, a few of them are used as preservatives for the specimens in laboratories. Ether is an organic compound containing an oxygen atom bonded to two same or different alkyl. The general formula for ether is ROR, wherein ethers can be generally classified into two categories based on their attached substituent groups. First, symmetrical ethers, two identical groups attached to either side of an oxygen atom, and the other one is asymmetrical ethers, two different groups attached to either side of an oxygen atom. Here is an example of asymmetrical and asymmetrical ethers. In naming ethers, the word ether is always added to the names of the two alkyl groups attached to the oxygen. Just like in our example, diethyl ether as an example of a symmetrical ether, and ethyl-methyl ether as an example of an asymmetrical ether. Properties of ethers. An ether molecule has a net dipole moment due to the polarity of carbon-oxygen bonds. The boiling point of ethers is comparable to the alkanes but much lower than that of alcohols of comparable molecular mass despite the polarity of the carbon-oxygen bond. This miscibility of ethers with water resembles those of alcohols. And ether molecules are miscible in water. This is attributed to the fact that, like alcohol, the oxygen atom of ether can also form hydrogen bonds with a water molecule. Uses of ethers. Ethers are organic compounds with a sweet smell at room temperature. They are colorless and evaporate quickly when exposed to air. It is flammable and hence catches fire very easily and therefore should be handled with care. Being flammable and volatile, it is used in cold weather to start a diesel or petrol engine. It is also used as a refrigerant. Ethers are used as an antiseptic in order to prevent infection when an injection is administered into the body. A cotton ball is dipped in ether and skin is disinfected before an injection is allowed to pierce the skin. Diethyl ether is used as an anesthesia in hospitals. Anesthetics help in making people go to sleep or become unconscious during surgery. Aldehydes and ketones. Aldehydes and ketones incorporate a carbonyl functional group, carbon double bond to oxygen. These are organic compounds with structure CHO and RC double bond OR, where R and R represent carbon-containing substituents respectively. The carbon atom of this group has two remaining bonds that might be occupied by an alkyl or substituents. If neither of these substituent is hydrogen, the compound is a ketone. If at least one is hydrogen, the compound is an aldehyde. Common examples of aldehydes. In aldehydes, the carbonyl group has one hydrogen atom attached to it, together with either a second hydrogen atom or a hydrogen group, which may be an alkyl group. In our examples, one can notice that all these have the same exact end to the molecule. The only difference is the complexity of the other attached group. In IUPAC naming, the suffix al or aldehyde for common names is always added to the name of an aldehyde. For example, we have methanal, ethanal, propanal, and 2-methylbutanal. Common examples of ketones. In ketones, the carbonyl group has two hydrogen groups attached to it. This can be the one containing the alkyl group. Ketone does not have a hydrogen atom attached to the carbonyl group. In IUPAC naming, the suffix one or the word ketone for common names always ends the name of a ketone. For example, propanon, butanon, and pentan-3-one. Properties of aldehydes and ketones. Aldehydes and ketones have higher boiling points than hydrocarbons, but have lower boiling points than alcohols because they have no hydrogen attached to oxygen. Aldehydes and ketones have strong odors and are often used as flavoring or scents. And lastly, small aldehydes are reasonably soluble in water. Large aldehydes are less polar and dissolve more readily in nonpolar organic solvents. Uses of aldehydes. Formaldehyde is a gas with 40% solution in water. It forms formalin, which is used in preserving biological specimens. Formaldehyde is used in embalming, tanning, preparing glues and polymeric products as germicides, insecticides, and fungicides for plants. It is also used in drug testing and photography. When reacted with phenol, formaldehyde forms bakelite, which is used in plastics, coatings, and adhesives. Acetaldehyde is largely used for the production of acetic acid and pyridine derivatives. Benzaldehyde is used in perfumes, cosmetic products, and dyes. It is added to provide almond flavor to food products and also used as a bee repellent. Uses of ketones. The most common ketone is acetone, which is an excellent solvent for a number of plastics and synthetic fibers. In the household, acetone is used as a nail paint remover and paint thinner. In medicine, it is used in chemical peeling and for acne treatments. Methyl ethyl ketone or MEK, chemically butanon, is a common solvent. It is used in the production of textiles, varnishes, plastics, paint remover, and paraffin wax. MEK is also used as a welding agent for plastics due to its dissolving properties. Cyclohexanone is another important ketone which is primarily used in the production of nylon. Carboxylic acids is an organic compound containing a carboxyl functional group. They occur widely in nature and are also synthetically manufactured by humans. The general formula of a carboxylic acid is RCOOH, where COOH refers to the carboxyl group, and R refers to the rest of the molecule to which this group is attached. Based on the illustration, it can be observed that a carboxylic acid contains a hydroxyl group attached to a carbonyl group. Due to the electronegativity of the oxygen atom, this functional group can undergo ionization and discharge a proton. The carboxylate ion, produced from the removal of a proton from the carboxyl group, is stabilized by the presence of two oxygen atoms, through which the negative charge can move. Some common examples of carboxylic acids include acetic acid, a component of vinegar, and formic acid. Examples of carboxylic acids. The guidelines that must be followed in the IUPAC nomenclature of carboxylic acids are listed below. The suffix E in the name of the corresponding alkane is replaced with oic acid, just like methanoic acid, carbonic acid, butanoic acid, and butyroic acid. When the aliphatic chain contains only one carboxyl group, the carboxylic carbon is always numbered 1. For example, CH3, COOH is named as ethanoic acid. These are common examples and structures of carboxylic compounds: methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and pentanoic acid. Properties of carboxylic acids. Carboxylic acid molecules are polar due to the presence of two electronegative oxygen atoms. They also participate in hydrogen bonding due to the presence of the carbonyl group and the hydroxyl group. The solubility of compounds containing the carboxyl functional group in water depends on the size of the compound. The smaller the compound, or the shorter the R group, the higher the solubility. The boiling point of a carboxylic acid is generally higher than that of water. Uses of carboxylic acids. Fatty acids that are essential to human beings are made up of carboxylic acids. Examples include omega-6 and omega-3 fatty acids. Higher fatty acids are also used in the manufacture of soaps. The production of soft drinks and many other food products involve the use of many carboxylic acids. The manufacture of rubber involves the use of acetic acid as a coagulant. Uses of carboxylic acids. Hexaneodoic acid is used in the manufacture of nylon 6,6. Carboxylic acids have numerous applications in the rubber, textile, and leather industries. Ethylene diamine tetraacetic acid, or EDTA, is a widely used chelating agent. The synthesis of many drugs involves the use of these compounds. Therefore, carboxylic acids are very important in pharmaceuticals. Esters are the group of chemical compounds which are formed by bonding of an alcohol group with a group of organic acids by losing water molecules. Based on the illustration, esters are also usually derived from carboxylic acids. Ester is formed when carboxylic acid and alcohol react with water as a byproduct. Esters feature a carbon-to-oxygen double bond that is also singly bonded to a second oxygen atom. Esters are named by using the first group from which the alcohol is derived and then the group from which the carboxylic acid is derived. Then, the suffix ate is added. These are some common esters used for flavoring. Uses of esters. Esters that have fragrant odors are used as a constituent of perfumes, essential oils, food flavorings, and cosmetics. It is used as an organic solvent. Natural esters are found in pheromones. Naturally occurring fats and oils are fatty acids esters of glycerol. Nitrate esters such as nitroglycerin are used as explosive materials. And lastly, polyesters can be further converted into fibers to make clothing. Amines are one of the most important classes of organic compounds which can be derived when we replace one or more hydrogen atoms of ammonia molecules with an alkyl group. Simple linear amines are named by specifying the alkyl groups attached to the nitrogen atom and adding the ending amine. Uses of amines. It is used in water purification, medicine manufacturing, and development of insecticides and pesticides. It is involved in the production of amino acids, which is the building block of proteins in living beings. Many varieties of vitamins are also made by amines. Serotonin is an important amine that functions as one of the primary neurotransmitters. It controls the feelings of hunger and is critical for the speed with which the brain operates in general. Pain-relieving medicines such as morphine and Demerol, which are also known as analgesics, are made from amines. When an amine containing hydrogen reacts with carboxylic acids, amides are formed. The amide functional group is derived from the conjunction of hydrogen of an amine with the OH of a carboxylic acid producing a covalent bond and water. To remember an amide structure, all you need to know is a nitrogen atom should be present in an amide compound. First comes the carbonyl group, wherein a carbon atom is double bonded to an oxygen atom. Second comes the amine group, wherein a nitrogen atom shares a single bond with R groups. You can consider R groups as substituents of other atoms or molecules to connect in a structure. And lastly, a single bond, which is also a characteristic functional group of an amide. The above picture describes the structure of three kinds of amides. The positioning of the nitrogen atom is not common for three different amides. A nitrogen atom links to a single carbon atom in case of a primary amide. The nitrogen atom links with the two carbon atoms in case of secondary amine, while in tertiary amide, the nitrogen links itself to three carbon atoms. The most important naturally occurring amide is protein. The structural formula of protein is shown below. Thank you for watching. Do not forget to subscribe for more science educational videos by clicking the notification bell.